Hello everyone, my name is S.N. Patil. In this video lecture, we discuss the bisection method to find approximate root of the polynomial. The bisection method is used to find an approximate root in an interval by repeatedly bisecting into subintervals, which is based on the intermediate value theorem for continuous function. Okay. Now, first we see the diagram. Now see, this is the curve is passing through the interval A. This is the A point and this is the B point. Okay. Now, what is intermediate value theorem? Now this method is based on the intermediate value theorem. So first we define the intermediate value theorem. Let f of x is continuous on the closed interval AB, okay, such that f of A and f of B having opposite sign. Opposite sign means what? F of A either negative, if f of A is negative and f of B is positive, okay, such that f of A into f of B means their product, f of A into f of B is negative. F of A into f of B is negative. Okay. If suppose it has the same sign, both are the negative, then their product it become positive. If both are the positive, then product is positive. So there should be a opposite sign to f of A and f of B. Okay. If this product is negative, it means there exists root. There exists root x naught belongs to closed interval AB. Okay. Now here we have the interval AB, and from that interval curve is passed, and this is the root. This is the root here. So in bisect method, once we identify the interval from which the curve is passed, then the first step we bisect this interval. Okay. So here from this conclusion, that is root lies between A and B. That is the step first is here. We bisect this interval as a x naught is equal to A plus B divided by 2. Okay. If now this is the approximate root. Okay. If f of x naught, put x is equal to x naught here in polynomial. If this value is 0, then x naught is root. X naught is a root. X naught is a root of polynomial f of x. If not, means if f of x naught is not equal to 0, then it has the two possibility. Suppose this is the x naught. Then first possibility, the root lies between A and x naught. Okay. Otherwise, root lies between x naught and B. Okay. This is the for example. Not always the root lies between the second interval. This is the example. If f of x naught is not equal to 0, then there are two possibilities. Then root lies between what? A and x naught. A and x naught, or x naught and B. X naught and B. Then how we can identify in which interval the root lies? For that, check the value of f of x naught. If f of x naught is negative. Okay, now here the image of f of a is negative. We just assume if f of x naught is negative, f of x naught is negative, then from this diagram, what we conclude? F of x naught is negative. Then what is the conclusion? See, this is negative sign, this is the positive sign. Okay, it means the root is lies between between x naught and b. Okay, this is one possibility. If this value is positive, if f of x naught is positive, suppose we got this positive. Okay, then here the same sign. If same sign is there, then there will be no root in that interval. Now here negative sign, negative and positive, then root is lies between a and x naught. Okay, now this is the first step. Now the second step, we make it generalized. Now consider x1. Okay, the next iteration is x1, and instead of this we consider a1 and b1. a1 plus b1, the root is lies between a1 and b1. We bisect this interval as the same, divide by 2. Okay, if f of x1 is 0, then x1 is root, then x1 is root of f of x. If not, means f of x naught, f of x1, sorry, f of x1 is not equal to 0, then continue above process until we get desired value. Yeah, accurate root. Okay, now here just wait. Now we repeated this process up to nth step. At the nth step, the number, we find the number of iteration. How many number of iteration should be there so that we get the accurate root? So how we can find the iteration, number of iteration? Suppose at the nth step, the interval an comma bn, and the length of the interval is b minus a divided by 2 raised to n, because every interval we divide into 2 parts. Okay, it means this value is very small. That is means we bisect the every interval and we close to the desired root. Okay, so that this value is very small, that is less than epsilon. Epsilon is less than epsilon. Now taking log both side, it is the natural log of b minus a divided by 2 raised to n is less than log of epsilon. Here we find the value of n. Okay. Now apply the log of logarithmic property log of b upon a, means log of b minus a. So it can be written as log of b minus a minus log of 2 raised to n is less than log of epsilon. Okay. Now we want the n. Okay. Now put log of 2 raised to n in right hand side. So it can be written as log of b minus a minus log of epsilon is less than log of 2 raised to n. Now log of a minus log of b, apply the property, it can be written as log of b minus a upon epsilon is less than or is equal to, apply logarithmic property here, log of a raised to b. Log of a raised to b is b into log a. Okay, so it can be written as n log of 2. Now log 2 is divided here. We get n is greater than log of b minus a divided by epsilon and divided by this log 2. Okay, so here n indicate the number of, here n indicate number of, minimum number of, indicate number of iteration for desired accuracy. Okay. Now let us take the example. Now using the bisection method, find the approximate root of this polynomial. Okay, and perform the 5 iteration. So we have the polynomial f of x is equal to x cube minus x minus 4. So here we use the trial and error method. Here we use the trial method. We identify the interval. So here we start from the 1. Okay. Now we put x is equal to 1 in polynomial. So here we use the intermediate value theorem. Okay. For that we use the trial method. So put first x is equal to 1, that is 1 cube minus 1 minus 4. So here we get the value is minus 4. We put 2, x is equal to 2 here, 2 cube minus 2 minus 4, that is minus 6, and plus 8, that is 2. So we get opposite sign. See, this is the f1 and this is the 2. We get f of 1. F of 1 is negative. Okay, I'm just write here negative sign. And we get f of 2 is positive sign. The product of f of 1 and f of 2, if we calculate, then minus 4 into 2 is minus 8 is negative. By intermediate value theorem, see the f is continuous. This is the continuous, and f of a and f of b having opposite sign. That is, their product is negative. It means root lies between what? 1 and 2. 1 and 2. Okay. Now the next process, we bisect this interval. From intermediate value theorem, we got root lies between 1 and 2. Now we bisect. Now this is x naught. Okay. Now the x naught is a plus b. This is the a point, this is the b point. That is 1 plus 2 divided by 2. That is 3 upon 2. That is 1.5. Now this is a root, suppose. Suppose this is equation 1. Put in equation 1. In equation 1, that is f of x naught. F of 1.5 is equal to, put 1.5 here, 1.5 raised to 3, 1.5 minus 4. By calci, now I'm putting direct answer here. Through calci, calculate this value. So we got here minus 2.125. Okay, so we get f of 1.5 is negative. Now from this diagram, we identify from which interval the curve is passed. See, this is the negative sign and this is the positive sign. That is opposite sign of function. Okay, here the same sign. The root is not passing through. The root is passing through. This is x0 point, means 1.5, and this is the b point, that is the 2. The value of f of 1.5 is negative and the value of f of 2 is positive. Okay, every time we want same kind of the nature, that is positive, negative, yeah, negative, positive, whatever. So from this we can conclude the root is lies between 1.5 and 2. That is, root is lies between 1.5 and 2, because since f of 1.5 into f of 2, f of 2 is negative. Okay, now bisect this interval. So this is the x1 point. x1 is equal to 1.5 plus 2. Take the addition. Okay, that is the we bisect this and divide by 2. So we get 1.5 plus 2, we get 1.75. Okay, now put this value. So what we get, x1 is equal to 1.75. Put in equation 1. Equation 1. Substitute here. The equation 1 is f of x1, f of 1.75, okay, is equal to 1.75 raised to 3 minus 1.75 minus 4. So through calci we calculate this value, minus 0.390 625. So here the value of f of x1 is minus. So here the same sign, the root is not lies between x0 and x1, and here the opposite sign. Okay, see, we get the opposite sign, that is f of 1.75 into f of 2. Its product is negative. It means root is lies between x1 and 2. x1 is 1.75 and 2. Now bisect, that is the next iteration. Say x2, 1.75 plus 2 divided by 2. Okay, so we got this value as a 1.875. okay, that is x2 is equal to 1.875. Put in equation 1. Equation 1. See, this is the equation 1. Substitute in equation 1. Then equation 1 become f of x2 is equal to f of 1.875 x2 1.875 is equal to 1.875 raised to 3 minus 1.875 minus 4 is equal to 0.716796. Okay. Now here we get the positive value. See, the root is lies between 1.75 and 2. Then we bisect this as a x2. Okay, so x2 we got 1.875 and its value 1.875, we get the positive value. Okay, so remaining this interval we get f of x2 is a positive. So here the same sign, root is not lies between these 2 points. Root lies between these 2 points. Okay, that is root lies between the product 1.875 into 1.75 is negative. That is root is lies between is what? This is the x1 is 1.75, 1.75 and 1.875. Now bisect this. This is the 1 point. We call this x1 1.75 and this is 1.875. So here we get the negative term, negative value, and here we get the positive. Now we bisect. So this is what? This is x2. Now this is x3. That is x3 is equal to, we bisect 1.75 plus 1.875 divided by 2 is equal to, we got this value as a 1.8125. Now put this value in equation 1. Put in equation 1. Equation 1 become f of x3 is equal to f of 1.8125 is equal to, we substitute here in equation 1, 1.8125 minus raised to 3 minus 1.8125 minus 4 is equal to we get through calci, we get here 0.1418457. We get positive value. So this is, we get positive value. So here this is the same sign, the root is not lies between this. So root lies between these 2 points. That is their product definitely is negative. F of 1.75 into f of 1.8125 is negative. That is root lies between, lies between 1.75 and 1.8125. Okay, now we bisect this. So this is the x4 point. That is x4 is equal to 1.75 plus 1.8125 divided by 2 is equal to 1.7812. Okay, now put this value 1.78125. Put in equation 1. Put in equation 1. That is equation 1 become f of x suffix 4 that is f of 1.78125 is equal to 1.78125 raised to 3. See, we put this value in equation 1. Now this is the equation 1. Substitute x is equal to, okay, minus 1.78125 minus 4 is equal to minus 0.1296081. So we get negative value. Okay, so here we get the negative value. So here we same sign. Root is not lies between these two intervals. So root lies between x4 and x3. Product f of 1.78125. This is the x4 value, and f of x3 means 1.8125. Its product is negative. That is root lies between 1.78. The x4 is 1.78. Sorry, 1.78125 and 1.8125. Now bisect this. Now this is the last iteration. X5 is equal to 1.78125 plus 1.8125 divided by 2. So we get the value as a 1.7968. That is the fifth iteration. Actually, this is the sixth one. X5 is equal to 1.7968. Okay. So this is the approximate root, which is approximate root. Root of equation 1. Now see, in equation 1 clearly mention the 5 iteration. So go up to 5 iteration. Okay. So this is the fifth iteration. So this is approximate root of the equation number 1. Okay, using the bisection method. Now similarly for you, these are the problem. This is the first problem. Homework for you. Okay, and these are the remaining 3 problem. Okay, for you. Solve all this problem using bisection method. So these 3 problem perform only 3 iteration, and the second one, this is the second problem, here perform the 4 iteration. Use the same technique. Okay, thank you.